This is CLO1. This is my unit testing. So I used something called JUnit 5. As you can see, I ran over here. All of the 5 tests passed. I did checking the OLED, checking whether the pump turns on and off, checking the graph, and etc. Okay, so this is my setup. That's my Arduino, my watering pump, and my plant. And then this is my code. It took a couple seconds to turn on, but as you can see, the OLED shows that the soil is dry and the pump is on. The voltage is above my threshold of 2.7. So then the water is on and it's watering the plant. And then if you look at the graph, it started at around 50% moisture and it goes down to 0. When it's at 0, the OLED says that it stops and the pump is not watering anymore. So as you can see over here, the pump is off and the soil is wet. Yellow 2 asks how we use Fermata and Princeton in our code and how it works. So Fermata is basically a library that we downloaded, which is used to communicate with the microcontroller, which allows me to use stuff like the sensor data and control the pump. So over here, I use a get pin from the Arduino board. I also use it for set value. And then if we want to look at Princeton, which is the STD lib, we use stuff like STD draw and STD filled the circle over here, which was able to visualize the moisture data over time. Yellow 3 asked how we use collections for data storage to manage moisture readings efficiently. So I use Java's built-in array list as well as the addition of linked hash maps. So in this class, you can see I used array list to store the sensor readings, ensuring that we could plot it on the graph. And then over here on the moisture grapher, I actually used the linked hash map, which is used for timestamps and corresponding with the dryness percentages, which I indicated over here, which is 540 and 720. And then I use this if else statement to actually plot it with the raw value of the equation. Before we have to explain how we use event-driven programming for this plant watering state machine. So I showed how it continuously monitors the sensor and determines whether it should be turned on or off using this if-else structure. Also use the OLED display to dynamically update with real-time readings such as the draw string over here, and it shows the voltage, the moisture sensor, whether the pump is on or off, and whether the soil is wet or dry. 5 asked how we use OOP and iterative refinement for the following code. So I used encapsulation for the following classes: OLED display, moisture logger, and moisture grapher, which basically I added refined logging, an OLED interface, and a dynamic graph to improve usability.